Okay, so we're doing the last two of the evaporative cooling process. So I have two temperature probes. The last two samples were methanol, which we have here, and distilled water. And we're going to use the same thing. So if you come around to this side, and actually you can kind of video me putting these on here, I suppose. But I'm going to put a little bit of methanol. Actually, let's hit the start key first. Let's hit start. We'll start taking our data, and then I will put a little bit of methanol on that one, and put a little distilled water on this one. And we'll go take a look at our data for that 3-minute or 180-second span. Okay, see if we can get that set up on there so you can see. That's pretty good. All right, so what we're seeing is the methanol is the blue, I believe. It's the first one. And then the second one is the water. And so we'll just watch this through, and then we'll pick a segment. The starting temperatures for both of these were 21.1. I forgot to tell you guys, hey, this is the starting temperature, but it was 21.1 for each. And we'll see what their final temperatures will be. And we'll do the same thing. We'll select a portion of the graph that was quite linear, so it gives us good data, and then we'll go capture the slopes of both of those lines. So it looks like our data is coming out pretty good, pretty well, actually. And I'll stop there at 180 seconds, and we'll go ahead and take a look at our slope data. So look at your final temperatures there. The initial temperature was 21.1. Our final temperature, let's see if we can get the final temperature on there. I didn't think about that in the last graph either. Go ahead and pick that up. But okay, I'm going to take this down and look at it here. We're going to select a region of the graph that kind of best represents what's happening. If you look at the methanol, this is a really good region for the, well, not that one, but this is a really good region. Nope, not that one. This is a good region for the methanol here. This flat area over here is after a while. So what we want is we want that initial period. Let's see, there we go. Back in like there. A couple of data points, but that's okay right there. So we'll look at this data right here for the blue one. We'll select a different region for the water because it looks like the water went up and then back down. We'll pick a little pace after that. But okay, so for here are our final temperatures. So final temperature for channel 1, which was the methanol, was 17.5. Actually, that's not true. There it is. The final temperature for the methanol was 14.0, and the final temperature for the water was 18.3. My apologies for that. This was just looking at this one little sample. I really kind of wanted you guys to see where it started at the beginning of the lab and where it finished at the end of the lab. But for our data, for our slope, we're going to find that part where it is most linear. So looking at that position or that place right there, we'll go to analyze like we did yesterday, like we did in the lab a minute ago, and we'll go to curve fit. we'll select, ooh, we should have selected the other one, shouldn't we? Let's go back. We should have done the blue one first, which is the methanol. So analyze curve fit for the methanol. And the fit we'll choose is going to be linear. And the slope that you'll want is negative 0.116. That's definitely the highest slope that we had of any of those. Think about how this is going to react. What we're going to want you to do is to kind of relate this to intermolecular forces, but this substance obviously is evaporating pretty quickly. Let's go ahead and select a region for the water this time, and I'm going to select right in there for the water. That's pretty good. So we'll look at the water there, and so let's go back to analyze, do our curve fit. We'll come look at the water change, so it's just selecting that region there that I determined was quite linear. And so our linear data, here is our slope of our line for the water. It's negative 0.024714. Go ahead and include all the digits, that's fine. And so that'll take care of our slopes for both of those lines. Yeah, so that was all 5 of those. Make sure that you have the slopes of each of them. You do need the initial and final temperatures of both of them. On the first 3, you may have to go back and look in the video and see where they were because I didn't point them out. I apologize. But there you go. So that is the first part of the lab. I'll see you guys in the part 2 of the lab.